Okay, so welcome back, guys. I haven't recorded or uploaded a video in a while now, so I thought I'd upload one. This one seems pretty good, and I like roughly tried it out. So, but I haven't tried it out completely. I just tried out like one case, and we're gonna start with that case. So the question says, the floor of x plus 1 over x is equal to the floor of x squared plus 1 over x squared. And just to define the floor function, the floor function, I guess, maps out. Okay, so if x is an element of the integers x, solution, if x is not an element of the integers, maps out to the m less than x, less than m. Okay, that's just ludicrous. M less than x such that m is an element of the integers, right? Basically, if you have like floor of 2.8, then you just get 2. Okay, you have floor of 4, you get 4, right? You have floor of square root of 2, say, which is like floor of approximately 1.414. That's 1. That's good enough for the approximation. Okay, so anyways, those are examples and definitions straight out the gate, right? Good enough. Okay, so now we have, okay, let's see, x. Okay, so let's start by assuming the first case, right? So let's do case 1. X plus 1 over x is an element of integers, right? And of course this directly implies that x squared plus 1 over x squared is an element of the integers, because I'm just gonna make a note here. X squared plus 1 over x squared is equal to x plus 1 over x squared minus 2. So because this is an integer squared minus 2 is still going to be an integer, right? So that's good enough. Yeah, okay, I think we're going to need that part too, right? Yeah, we are actually. So okay, we get x plus 1 over x is equal to x squared plus 1 over x squared. Okay, that's pretty good. Now we're just going to plug in this here directly. So x plus 1 over x is equal to x plus 1 over x whole thing squared minus 2. And this is not that tough to prove. It's like literally a two-step thing, right? Basically. So yeah, now moving everything to the right hand side, we get I'm gonna move in the right hand side and then move to the left hand side, stuff like that. Basically we're gonna form a quadratic in terms of x plus 1 over x, right? So x plus 1 over x whole squared minus x plus 1 over x minus 2, and this is equal to 0, right? So let m equal x plus 1 over x, right? That's pretty good. So x plus 1 over x whole square, right? So we get the quadratic m squared minus m minus 2 is 0. And notice that 2 doesn't depend on the value of m, so that's a constant term, just in case you were worried about that. This is a valid quadratic. Okay, so we have to find two numbers such that they add up to minus 1 and multiply to minus 2, which is easy enough to do. M squared plus m minus 2m minus 2. This is pretty good, right? And it's not that tough to verify that this is equal to this expression. So okay, yeah, so factoring out an m from here, m plus 1 and minus 2 from here, so you get m plus 1 is equal to 0. So m minus 2, m plus 1, this is all equal to 0, of course. So from here we get two possibilities, right? M is equal to 2 or minus 1. Now, okay, right, we'll just verify those possibilities one by one, I guess, because we are savages. Yes, that's what we are. Okay, now this should be easy enough. 2, so we get x square. Okay, wait, what was I doing? Man, ADD sucks. Now this should be equal to 2, right, for the first case. So It's not that tough to form a quadratic. X squared minus 2x plus 1 is equal to 0. A lot of quadratic stuff today. Wait, what? 2x x squared plus, okay, that makes sense. But basically you don't need to form a quadratic, you get a solution directly. I want to form a quadratic anyways, because that's just me. So yeah, 4 minus 4, the determinant is 0, so we get two literally exactly same solutions. And of course, if you're smart, you already saw that x minus 1 whole squared is the value for this one. Therefore x is 1. That's one of the solutions. Right? Now for the second solution, we use this minus 1 case, right? So I'm gonna write it up here. This is followed up here, right? Okay, so we get x plus, okay, so x equals minus 1. So x plus 1 upon x, m equals minus 1, so x plus 1 upon x is minus 1. Now this is again, it's like a trivial quadratic form. So plus x plus 1 is equal to 0. But now you'll notice that this quadratic doesn't have real roots. Okay, if you go to solve it by the quadratic formula, you get this stuff, right? And then you get b squared, which is 1 minus 4, and of course this is minus 3, square root of minus 3, that's not real, and something, as I write it out here. So this is not an element of the reals, therefore yeah, m cannot be, no, m can be, sorry, pardon me, but x, no, actually m cannot be, right? Yeah, m cannot be minus 1. So we have one solution so far, x is equal to 1. That's actually pretty trivial to see, right? And that's how far I got in my head. Of course, I know there's a second case where this is not an element of the integers and it's like a little larger, a little smaller than that or something. Yeah, it's annoying. So there's going to be an annoying case. Hopefully not too annoying, because I can rage quit, alright? Anyways, case 2. X plus 1 upon x is not an element of the set of integers. Okay. And of course, these are all integers. As you can see, I've never assumed that it's a positive or negative integer. So, and of course x cannot be 0. That's trivial to see, hopefully. Yeah, so okay, and actually one was pretty trivial solution, right? You can just eyeball this thing and you can say 1 plus 1, 1 plus 1. That makes sense to any reasonable person. That would make sense. So okay, now I'm gonna do a thing, right? So x plus 1 upon x plus an alpha. This is not equal to anything. This is element of the integers. Okay, good. Now this is an element of the integers, meaning that, and of course, oh wait, should I say plus? No, I think I should say minus alpha, right? Yeah, minus alpha, because you're using the floor function here. Minus alpha is an element of the integers where, okay, so alpha is of course greater than 0. God damn it. Yeah, greater than 0, but it's also, did I say less than 0? Okay, greater than 0, but it's also less than 1, because if it was 1, then just like overdo it, right? Yes, so that's basically that, so that we don't have to use the floor function, because it's annoying. So okay, let's see. So we get plus 1 upon x minus alpha. Let's square this thing, right? Okay, whole squared. Okay, so we should get okay, so we get x. What I want to mention a little formula down here, bottom right. Okay, so a plus b plus c whole thing squared. This is I'm just going to use advanced notation because I am lazy. A squared plus 2 sigma ab. This basically means like all the possible ways you can like have singular squared terms and all the dual products, right? So basically that should be a pretty trivial formula. It's not that tough. You can just prove that by, I don't know, multiplication of trinomials. That's, yeah, it's not that tough. So okay, I'm going to use this formula right now. X squared plus 1 upon x squared. That's what we want, right? That's the thing we want right now. Okay, and then we have a plus, yeah, it's kind of minus, but it doesn't matter, right? So we're just gonna say plus alpha squared. But okay, so keep in mind this alpha is it's a positive number, right? But that thing squared, huh? So okay, assume that this is like plus minus alpha squared, right? Because that's the same thing, really. Realistically speaking, that's the same thing. And minus alpha whole thing squared is still alpha squared, because square things they're not that hard to understand. Okay, and then we have plus. Okay, so we have AB, right? That's just 1 plus BC, which is minus alpha over x, if I'm not wrong. Yeah. And then we have plus AC, which is minus alpha x, sorry, alpha x. And I use an A because I am fancy. Anyways, so that's the quantity we want, right? Okay, good enough, good enough. So we have x squared plus 1 over x squared. This stuff should be equal to, okay, and now from here we can factor out a minus alpha, right? This stuff, okay, get a plus alpha squared minus alpha x plus 1 upon x. Yeah, that's good. And then we get a plus 1. Yes, good, good. And this should be equal to stuff, basically stuff. This thing, I'm just gonna have to write it out, aren't I? I can't be lazy. Plus minus alpha, this whole thing squared. Okay, so now we get another, like, is that like a quadratic in alpha? That's quadratic in alpha, that's just the weirdest thing, because mostly we use alpha as like the thing for the roots. Yeah, that's really weird. Okay, so anyways, x squared plus 1 upon x squared, right? And then we have, okay, and a squared. Let's see, I'm really dumb, so I'm gonna have to plus or minus the square root of and then minus 4ac, so basically minus 4, so that's minus 2 upon 2, of course. So we're gonna do this using the quadratic formula. I'm gonna rub this off later, but if you want to see things in the quadratic formula, then I have videos on that, go check them out. And this should be an easy thing to bring out of the square thing. So we get an x squared minus 1 upon x squared, square root of that stuff. So x minus 1 upon x, right? Yeah, upon 2. Okay, so the first solution we get is, okay, so let's say this is plus, right? So this implies that the first solution is 2x upon 2, which is x for this, and the second solution is 2x, no, so the second solution is x plus 1 upon x for this quadratic in alpha. Oh, this was weird. It's so weird, so weird. Okay, so those are the two solutions. So we get plus alpha minus x, alpha minus x plus 1 upon x, but like the minus comes inside, and x minus 1 upon x is equal to 1 upon x plus minus alpha squared. Okay, this is so large, and I'm gonna rub this off, of course, as I said. Just look at that if you're like bad at quadratics or something. No, it's not that. Well, it's not that easy either, to be fair. Yeah, square roots can be confusing when you have a lot of variables, and so yeah, I don't blame you if you're bad at that stuff, but just get good. Okay. Man, what do we want, right? We want some constant. So why did I do that stuff? Okay, I am dumb. I don't need to make a quadratic. I just overcomplicated this entire question. Okay, so I'm gonna rewrite this whole thing. So I have a dream. Alpha squared plus 1, and this is equal to x plus 1 upon x minus alpha whole thing squared minus alpha x plus 1 upon x. Okay, now we have this thing plus a constant and something is good enough. Yeah, that's actually pretty good. Okay. Damn, is this bad? Okay. So yeah, I don't think. Okay, so I mean, x equals 1 is surely a solution, right? But I want to find like other non-trivial solutions. Oh wait, okay, no, I just got this, right? So everything I did, I think in the past 5 minutes, is it 5-6 minutes, is absolutely rendered useless because I have a big brain and I finally figured out my big brain strategies. So okay, here we go. Here goes nothing. If I am really bad at math, then I'm sorry, I guess. I don't know. So here's the thing, right? We have x equals 1, but we're using a floor function, and x equals 1 is what we want. But what we really want is the floor of x is equal to 1, which means that really our value sets are infinite, right? So for this we get x is, okay, so x has to be, well, yeah, it has to be greater than 1, but x has to be smaller than 2. That's all. Okay, greater than or equal to. And that's the final solution. Okay, there it is. That's the real solution. We have infinitely many answers. Yes, we do have infinitely many answers. I hope you enjoyed my bickering here, but remember that if you get a smarter solution, you don't need to be dumb. You can rub off the dumbness. Just keep going, never give up. That's the point. So that was brilliant. I love that. Yep. Nice.